So hi, my name is Avi. I am a software team lead at Innovid, working in Innovid's measurement group. And today I'll walk you through how we at Innovid use Argo as a framework for all of our data workflows. All right, so a little bit background about me. So I am originally from Tel Aviv, currently living in New York City. I have a bachelor's and master's degree in mechanical engineering, specializing in robotics and micro electromechanical systems and fluid dynamics. After finishing my master's degree, I pivoted, started working with a small, short-lived startup as a backend developer. And after 6 months, that startup has closed, and I joined Innovid as a developer. Started working as a developer on our backend, front end, and cloud infrastructure. And about 2 years ago, joined our newly created measurement group, and am now a software team lead there. So today, I'll walk you through a little bit about how we at our measurement group use Argo for running our data workflows and DAGs. Why we chose Argo, what exactly is it, some core concepts that I'll walk you through, and some advanced features, and then we'll show some examples of how we use Argo at Innovid. So basically, we start with data. We all have data. It's located at different sources and at its raw form. And of course, to make sense of it, we need to we have some design questions about how to do that. We need to extract our data from different sources, whether it is on schedule or triggered by some event or manually. We then need to enrich, transform, join the data with other data to try and make sense of it and gain some insights. And finally, we need to load that data somewhere else, whether it is in order to send out reports for clients, whether it is to be consumed by our UI or consumed by other systems. So for that, we have the design question of how do we design, configure, and operate those data workflows, which are basically the sequence of tasks that we use to process our data. So at Innovid, specifically at our measurement group, we use Argo for that. So what exactly is Argo? So Argo is basically a workflow engine. It's designed from the bottom up to be able to define, configure workflows, and then schedule, trigger, and run them. And it supports complex data workflows. It's part of the Argo open source project. So there's Argo CD, Argo rollouts, Argo events, Argo workflows, and other projects. It's an open source project, so it started with a company called Appletics, which was then acquired by Intuit, and not so long ago was accepted into the Cloud Native Computing Foundation, which hosts other open source cloud-based frameworks like Prometheus. It has a very active and vibrant dev community. There's a Slack workspace, there's conferences, and it's being used by a lot of big companies. So why exactly did we choose Argo to work as our workflow engine at Innovid? You basically have a bunch of design options when creating a workflow engine. You can start very rudimentally with just deploying your code into some instance and then just scheduling it with a cron. Then you've got more complex frameworks like Airflow to run your more complex data workflows. The reason we chose Argo is most importantly because it's Kubernetes native. So it's all deployed as Kubernetes pods, all of the Argo framework, and it basically runs your workflows as pods in Kubernetes. Everything is all templates are defined as YAMLs, same way you define your Kubernetes templates. And most importantly, all the Argo objects themselves are Kubernetes CRDs, meaning they are custom resource definitions. They are native Kubernetes objects that Kubernetes understands. So basically, if you have the infrastructure for Kubernetes and you use, for example, kubectl, You can do all of that with your Argo objects. You can get, list, apply those using kubectl. All the permissions are based on Kubernetes RBAC-based permission system. So it uses service accounts with tokens. So all the security is comes pretty inside the box here, and it also comes baked with Prometheus. So you can basically, if you have Prometheus set on your Kubernetes cluster, you use it to scrape different Kubernetes metrics and run monitoring on your Argo. It has a full-featured UI, which is very easy to use, and there's a working demo that you can go afterwards and check out. It has native artifact support, so you can define outputs as artifacts that are then unloaded, whether it is to S3, Google Cloud Storage, or other repositories. And you get that out of the box, so basically you don't have to write any extra code for that. And there's a very useful REST API, again, secured with tokens that you can implement and use. So a little bit about security here. So as I've said, all Argo uses basically service accounts. So it has the built-in role-based access control for Kubernetes. You can define service accounts with varying degrees of permissions, whether it's an admin account, a viewer account. The API calls are all done using your service account tokens. So everything's secure in that sense. And you can also combine the Argo UI login with any OIDC provider you have, for example, using Google, in order to log in to the dashboard. And you can define different RBAC rules based on your users. So you can basically define a user as having the permissions of an admin or a viewer that is attached to a specific service account. The reason for the caveat here is that basically it's secure only to the degree that you secure it. Not so long ago, there was a series of attacks on Kubernetes clusters that have Argo that is basically misconfigured and is pretty open to the public. So those attackers were able to run pods on those Kubernetes clusters, and I guess you can probably guess that they use it to mine crypto. But that also got the NSA to produce a document on how to secure your Kubernetes clusters. So basically, this is all up to you. If you misconfigure it, it'll just might expose your Kubernetes cluster, but it has all the capabilities to be fully secure, based entirely on the way you configure it using service accounts, OIDC, SSO, logins, etc. As a workflow engine, it basically allows you to define your workflows as very complex workflows using DAGs, which are basically graphs that you can define the different dependencies between the steps in your data workflow. So this allows you to create very complex workflows that depend on other templates or workflows, and it gives you the option of choosing between whether to define it as a DAG, as a graph, or just as a series of steps. And these are basically equivalent, so you can choose how to use it. But it's very convenient, very robust in that sense, and that's because it's built from the ground up as a workflow engine. So let's talk a little bit about some core concepts in the Argo framework. It basically all starts with workflows and workflow templates. So a very rudimentary workflow would basically just define a workflow template and a specific one template that basically wraps a Docker container and then runs that container as a pod in Kubernetes. It has inputs that you can see here. It can have different outputs that you can then either upload to your artifact repository, or other templates can consume those outputs. But this is basically the basic workflow template. You can see that a lot of the stuff here are pretty equivalent in schema to the Kubernetes template schema, and that's also very comfortable because basically if you know Kubernetes and a lot of the stuff that Kubernetes supports, this would support as well. All the schema of a container node, for example, or other stuff. But of course, it's most powerful when you run more complex templates. And for that, you can actually define inside your workflow template a DAG or a series of steps, as I've mentioned, that basically runs a series of other workflows in sequence. And you can define those workflows that you can see here with dependencies between them. Every template here can either reference a specific template that is defined somewhere else, or you can even configure an inline template here. But this basically allows you to run a series of templates. They can take arguments as inputs. They can output arguments that the next step can then consume. And you can see here in a very basic example of a first step that uses a monitor service template to basically just send out a matrix to Graphite. Then you run another step, and then again you record the end of this workflow by firing another matrix to a certain monitoring service. So this allows you to create, it's very powerful, allows you to create a very complex data workflows. Now, there's a couple of ways you can schedule and run those workflows. You can manually execute the workflow that was defined in the previous slide by either manually running it or sending out an API request. Or you can you have more advanced features, for example, clones. So a clone workflow, again, is an object that is defined in the Argo project API version. It's a Kubernetes object. But basically, looks pretty much like the schema is defined very similarly to a Kubernetes cron schema. So you have a schedule, time zone, concurrency policy, pretty much everything that you could that a Kubernetes cron supports. This supports as well, and this basically just as you can see has a reference to a workflow template, and it would schedule that workflow template to run. You can supply the inputs that the arguments that workflow is expecting as part of that cron schedule. Now it's important to distinguish between the cron workflow and an actual Kubernetes cron. In a sense, this thing is not a Kubernetes cron. So Kubernetes is not scheduling this. This doesn't appear in Kubernetes as a cron or a cron job, if you're familiar with those Kubernetes objects. This is basically a Argo object. So Argo is actually the workflow controller, is basically responsible for scheduling this. And when scheduling it, it would just spin up a pod that would run this template. But this is in no sense a Kubernetes cron. It's an Argo cron, and Argo is scheduling and running these templates. Another way to execute workflows is by creating a workflow event binding. So this basically is an event that you can tie to some other thing, some other event, and fire an API request that then executes a specific workflow. You can see here there's a discriminator that it's basically a key that allows Argo to match this specific API event to the specific event workflow event binding. And this basically, when you fire up the event, you can then supply inputs or parameters in the event payload and basically trigger your workflows based on all kinds of events that are occurring. Right. So let's walk you through a little bit of some more advanced features that you get with Argo templates and with the Argo system. So here's an example of a conditional step. So you can basically have a sequence of steps, and some steps can execute or not based on specific parameters that you give it or specific conditions, as you can see here. There's also the ability to run specific loops. So for example, some steps can output parameters as their outputs, and then those can be consumed by the next step, which would then run on and loop on, for example, n items in that output, and basically run n amount of or n number of other steps. As you can see here, the first step here basically takes an output and then loops on 2 items in that output to create 2 different steps that run in parallel. So this is a pretty powerful feature. There's also an exit handler, which is very useful. We use it a lot. Basically, you can define an exit handler and a specific condition for that handler to fire up. For example, here you can see when the workflow failed, the exit handler is basically used to trigger another template that can fire a matrix to your graphite instance, for example, or fire an alert to your alert client like Opsgenie, for example. There are much more features that you just can't cover in a short presentation, but to name a few, you've got concurrency limits by label. So for example, you can limit the amount of concurrent workflows that run at the same time by specific labels. Those labels can, for example, be tied to specific resource in your production. So you can throttle the use of that resource in order to not have too many workflows running and using that resource. You have a workflows of workflows. So workflows basically just create pods which are Kubernetes objects. So the same way they can also create Argo workflows, which again are Kubernetes plus objects. So basically, you can create a workflow that takes in a parameter with, let's say, a number of items, and then runs a loop. And for those n items, creates n workflows that run and execute some sort of a task. As I've mentioned, there are output artifact repositories that are built in. So for example, S3, if you have a workflow that outputs something that that output can out of the box automatically be unloaded using Argo into an S3 prefix, where it can then be consumed by other systems. And this comes out of the box, so you don't have to write any other lines of code to manually unload those outputs into your S3 or other repositories. There's a very robust retry mechanism with backups, so you can create workflows that are very robust as well. There are other features as well. This is a living and breathing project that, again, there's a very large community that keeps adding more and more features on a very high frequency, I would say. So let's go over some examples of some basic examples to show you how we use Argo at Innovid and use the various capabilities that we've mentioned here. So this is a very basic scenario that we use. We have an S3 bucket with bucket notifications on top of it. And for example, whenever an object is created or deleted or not, you can fire up a Lambda function that can then send out an event using the Argo API and trigger a workflow that can process the data that was added. That Lambda can, or that event, the event payload can have the object prefix, bucket, whatever, and you can then fire out a workflow that consumes that data. Another example is how we use Argo in our CI/CD process. So we have different data workflows that we wrap inside a Docker image. So the way that we deploy those data workflows into Argo is basically by running them through our CI/CD process. We test them. We then wrap that code inside a Docker image and publish it to our Docker repository. And then we start a process of testing it. We first deploy it into our Argo staging environment, deploy the different workflow templates, clones, whatever. And then you can fire up a smoke test that would execute a workflow in that staging environment that would run on your test data to test the changes in that data end to end. And based on the exit code of that workflow that you can then parse in your CI/CD process, you can either halt the process or the deployment to production, or you can continue, if that was successful, deploy the new code, the new templates into production as workflows or clones or events, and then those clones would obviously run on a schedule. So it's pretty powerful way of actually testing your code every time you push changes end to end on your staging environment before you deploy your code to production. So another good example here of a workflow we have that uses loops is our backup workflow. So basically, one good side effect of having everything as a Kubernetes object here is that basically backing up all your Argo data is pretty simple. This is our Argo backup process. Basically, you can use kubectl to get all the current objects that living inside your Argo API, and you can then output those as output artifacts and unload those to S3. So you have a snapshot in time of your Argo instance, and then if anything happens, you can just then return everything to where it was using that snapshot, which is basically just a template of all the current objects. So that's pretty neat. As I've mentioned, Argo comes with a Prometheus port that it fires Prometheus matrix out of the box. So if you have Prometheus already installed in your Kubernetes cluster, it's very easy to create to use Prometheus to scrape different matrix on Argo, and then just create all kinds of dashboards, monitoring as well. You can monitor workflows, memory usage. You can monitor your workflow queues, saturation of the controllers, durations, pretty much everything you can think of. You can create a matrix for. You can also create custom matrix that you define in your workflow templates, but these are just the ones that come out of the box, and it's pretty powerful. So basically, to sum up, we use Argo Workflows because it's Kubernetes native. So if you have Kubernetes installed, you pretty much have everything you need to hit the ground running and start using Argo as well. It's secure if you configure it correctly. Obviously, the loophole is if you misconfigure something, then it's up to you. It's highly available, so you can basically deploy it to multiple of your environments, depending on your the way that you configured your environments and your Kubernetes clusters. And it also, each of those environments, it comes highly available. So there's highly available server pods, and there are highly available controllers, which are basically a leader, and you can scale horizontally to add more and more workflow controller pods and API servers, so you don't miss events, for example. It's extremely scalable, so you can restrict. You can have concurrency limits, or you can even restrict the number of workflows that run in parallel, either for a specific workflow controller, or set concurrency limits based on specific labels, so workflows don't run at the same time. You can define workflow and pod garbage collection. And as I mentioned, the Argo server pods and workflow controllers can be scaled horizontally. you define workflows very easily as DAGs or steps. So this allows you to create very complex workflows that depends on other workflows as well. And then you can execute those workflows either manually through the dashboard using the API. You can schedule them with crons, or you can set very complex scenarios and use event-driven execution to execute your workflows. So to start working with Argo is pretty simple. They have a very simple quick start guide that you can use right now. And depending on if you have Minikube obviously configured locally, you can just very easily spin up all the Argo for local use and start playing around with it. And it's very powerful, so we highly recommend it. And that's it. Thank you.